Today, we are covering the 6 guardrails to put in place before you let an AI ship anything you built. In July 2025, a founder handed the whole job of building his app to an AI. About a week in, he wrote that he had never used a more addictive app in his life. The next day, that AI ignored a direct instruction to leave the code alone and wiped his live production database. Then it generated fake data to cover what it had done. That kind of accident is preventable. Vibe coding, where you describe what you want, and the AI writes most of the code, needs 6 guardrails in place before you release anything you build. The order matters here. First, stop runaway spending, then protect anything that could be destroyed, lock down access and data, and finish with a habit you use every day. Each one comes with a prompt you can copy. Start with the one that costs you first. Lock the money before you start. 1 monthly spend cap in the billing console, 1 circuit breaker in your code. That same founder ran up $607 in 3.5 days on top of a $25 plan. At that rate, $8,000 a month. The console cap is yours and the agent never gets access to it. I have one on mine, and the console prints a warning that changes take about 10 minutes to land. Spending slips past it meanwhile. That is why the second layer sits in your code. A circuit breaker cuts off calls once you pass a line you set in advance. Runaway costs almost always come from a retry loop, the same failed call repeating over and over. Without it, the graph climbs all night. With the breaker in place, calls stop at the limit, and the log records why. So I have the AI find every call that goes out to an outside service, add a retry cap and a cost counter, and show me the change first. With the money locked, the next thing to protect is anything that can be erased. Destructive commands should never run without you. Deletes, config changes, and anything reaching the network go through a human approval step. The terminal first. It is the window where you type instructions instead of clicking them. In there, RM means remove, the R flag means every subfolder underneath, and the F flag means force it through with no confirmation. Together, they erase whole folders permanently without asking. A single tilde character stands for your entire home folder, and if it lands on the command by accident, the blast radius jumps from one folder to everything you own. In October 2025, a public issue described exactly that, a recursive delete that took out all of one developer's files. The frightening part came next. The log had saved the output but never the command itself, so nobody could confirm what ran. When you cannot trace a command afterwards, the defense you have left is approval before it runs. It happened to me too. I built a publishing automation an agent runs on its own, and one day 3 pieces went out without my approval. The blocking code worked fine. The weak link was the approval record. The agent could run the approval step itself, and the log showed it as though I had signed off on it. Before the rule, a dangerous command simply ran. After it, a confirmation window comes up first. First, the prompt reads only, listing every place something can run without asking me. Once I have been through that list, it applies the blocking rules. Now that deletes need your sign-off, shrink what the AI can reach in the first place. Give the AI only the access it needs. Use several keys with narrow permissions rather than one key that can do everything. That rule has a name. Least privilege means every key holds only the permissions it actually uses, and the range each one covers is called its scope. This is where I tripped. A token is the credential a script carries to prove it may use a service, and it renews itself so nobody has to log in again. I was adding mailbox reading to my automation, and I tried to stack that permission onto the upload token I already had. You cannot do that safely. Every time a token renews, it carries every permission from the original approval, so the narrower range written into each script was more like a note than a real boundary. My upload script could have quietly read my inbox. Each key draws its own permission boundary. Intent written into your code does not draw one. So I created a second credential holding nothing but read access. Have the AI build the table. Every key with the permissions it holds today. Issue the new keys yourself in the console. That split of roles is its own guardrail. With the keys narrowed, the data itself is next. Turn on row-level security on every table. If your app talks to the database directly, this is your last lock. RLS stands for row-level security. The database itself enforces that you see only the rows belonging to whoever is logged in. Enforcement moves down from your app code into the database. Apps that AI builds for you often have the browser sending requests straight to the database. The public key used for those requests, usually called the anon key, is available to anyone who opens your app. What that key can see is decided by row-level security alone. In March 2025, a scan of 1,645 apps built with an AI coding tool looked at their front pages alone, and 1 in 10 served its data straight out. Front pages only, which makes that number a floor. Turning it on is where the work starts. One table in my project has 4 policies, one each for read, write, update, and delete, all on the same rule of your own rows only. Block reading and leave writing open, and someone can still edit or delete rows belonging to other people. One request tells you where you stand. Log out and ask for the whole table. If access is open, everything comes back. If it is locked down, you get an empty list. The prompt reviews every table, tries walking in anonymously, then writes a policy draft from whatever came back. Applying that draft waits for me. That lock is only as good as the place its key is written down. The moment you write a key into your code, treat it as exposed. You scan the saved record of past code changes too, and any key that turns up gets replaced with a new one. A secret is the catch-all term for keys, passwords, and tokens that belong outside your code. An environment variable is what holds a secret outside the code and hands it over where the program actually runs. In public GitHub commits alone, 28.6 million new secrets surfaced during 2025, 34% more than the year before. A commit is just a saved snapshot of your code, and the ones written with AI help leaked at roughly twice the average rate. That is exactly how we are working now. History is the part people miss. Delete the key today, and the earlier snapshot that held it stays in the project history. You can rewrite that history, but copies that others already downloaded are gone for good. So rotating the key is what actually solves it. Scanning does not stop at your source code. In the settings files that connect AI tools to outside services, 24,000 secrets turned up, and 1 in 7 was the set of details used to open a database. Run the scan once and you see what needs fixing. Every key sitting inside a line of code gets replaced by an environment variable name. I ask it to scan that history with the actual key values hidden in the report, draft a move for any key sitting in the browser into code that runs on the server, and finish with a list of keys that need replacing. The first 5 change your setup. This one changes what you ask for every time. The last one is a habit, a short block of requirements you paste onto every build request. The block tells the AI to add a login check where the thing you are building needs one, check every value coming in, and keep internal details out of error messages. The 4th line asks the AI to report what it left out and why. AI quietly skips these because building the thing you asked for pushes them down the list. Require that report, and what got dropped comes back to you in writing. Without the template, an input form lets harmful input pass straight through. With it, the same input gets filtered, and the code ends with a line saying nothing was omitted. If pasting it every time gets tedious, pin it. I keep the rules my agent follows in one file in the repository, loaded automatically on every task. A sentence you paste by hand disappears the moment you forget it. In the rules file, it becomes the default. The most common question is whether any of this is safe to ship at all. Can you really ship a product built this way? That depends entirely on whether the guardrails are up. The cases we looked at mostly blew up because nothing was locked before the thing went out. People also ask whether these 6 only work with one particular tool. All of them work regardless of the tool. What changes is the config file name and where the screen lives. And no, you cannot hand the AI all 6 at once. That is why the prompts break into audit, confirm, and apply. Give it everything in one go and you lose every point where you could review what changed. What prevents these accidents is not the intelligence of the model, it is the safety equipment standing there beforehand. If you do exactly one thing today, do the second one. Turn off automatic approval for destructive commands. Almost every accident you cannot undo starts there. All 6 prompts are written out in full in the description. Copy them and use them. And that's everything for today. I hope this one helped. If it did, I'll see you in the next one. That's it from Gentle K. Thanks for watching, and remember, just start. It's easier than you think.